Hello and welcome to Lab 4, Physics 1. In our code, we see on the right, we set the ball mass to 0.402 kg. We put the initial position of the vector based on the tracker software. Initial velocity was 0. And then if you look down, we set the values for gravity, and we use the spring constant and L naught from the data in the video provided, and we calculated L by doing the initial position minus spring position, and then L hat, which is L over L hat, or the magnitude of L, and then we have S, which is just L minus L naught. And then from there, we use the different equations to find kinetic energy, gravitational energy, potential energy, spring potential energy, and then the total energy, which is just the sums. And then before we enter the for loop, we initialize all the values for the initial energies, and then we find f graph, which is just the mass times acceleration in the y direction, and then the force of spring, which is just ks times L hat. And then from there, we run the while loop, and yeah, our lab data, we see that it forms a harmonic motion in the shape of a ellipse on the top left image. And in the graph, we see the red and green, which is the spring potential energy and the gravitational potential energy. And then both of these are basically they're inverses of each other. So when one increases, the other one decreases by the same rate, and vice versa. While the delta E and delta K of the system are about equal throughout the whole thing. And then to the right, you see the x position over time for the model and then the experiment. And we see some variance in this case. But on the bottom, when it's the y position over time, they pretty much line up for the most part. What does this mean? So we can see that the energy principle is satisfied because the kinetic energy with the total energy, they line up pretty well. And then the gravitational potential energy as well as the spring potential energy, they are inverses of each other. So as one increases, the other one decreases. So when you sum them up together, they get 0 because energy could be neither created nor destroyed. And in terms of period of oscillations, for the y direction, based on the tracker graph that we have on the right, it would take about 2.18 seconds, while in the x direction it takes about 2.28 seconds. And from this, you could see that it takes a little bit longer to make a full oscillation in the x direction. But since the numbers are pretty similar, the motion is almost circular in the sense. So yeah.